Last part to number 48A. Remember, there were 4 parts. Let me just take a quick run through. It said write the balanced equation, which we did right here in blue. The standard EMF, which we did also here in blue using Appendix E. Calculate the delta G at 298, which we did in green. And now in red, I'm going to show you how to find the equilibrium constant. Now this is going to, obviously this is going to take a little bit. I want to make sure that you guys understand what's going on. Notice that in the last video where I stopped here, that this thing was not here, the thermodynamic electrical chemistry. If you check on this assignment, the last thing that's attached are the formulas for AP problems, for the AP exam. So I want to draw your attention here to the delta G standard that is equal to a negative RT ln K. This is the important part right there, natural log of K. So if I use algebra, I can go from delta G standard equals negative RT natural log of K and solve for the natural log of K, which means I divide both sides by RT like this, which means that over here I get a negative RT with delta G on top and RT on the bottom. Now we're going to have to maneuver some stuff here, because if you notice up here the delta G is in kilojoules. Well, if I change that to joules, then it looks like that. And the reason why I'm changing it to joules is because of this R value. So my natural log of K is going to equal the delta G. I'm going to rewrite the equation one more time. Delta G over minus RT like this, and if I plug in everything, then what I get is 48,800 joules on top, and then on the bottom I'm going to use my joules for the R value, which is 8.314, which is why I'm doing that. It's actually joules per mole Kelvin. So that's joules per mole dot Kelvin. And then the other part to this is the temperature. So the temperature is 298 Kelvin, like that. Okay, so all of this is going to equal the natural log of K, which means that we're not finished once we get this value. So this value ends up being about 19.708, and because the joules cancel over here, the Kelvin, this ends up being basically the natural log of this. This doesn't have units because of the natural log part, so we don't have to worry about that. But then to get K, we need to take E to 19.708 like this, and then that's how I get the answer of 3.61 times 10 to the 8th, or 3.6 times 10 to the 8th. Okay, go through all of that calculation yourself. I want to show you where I got this formula for the delta G equals a minus RT natural log K. I checked the book in chapter 20, and right around where we had the Nernst equation, I didn't see this equation, so I decided to attach, and I knew where to find this equation, so I decided to attach the formulas for the AP exam onto this so that you could see it. You can open that up and take a look at the thermodynamics and electrochemistry formulas. Okay, hope that helps. Send me a message if you have questions. Talk to you later.